So welcome back students to another lecture of NTT 205 Mineral Beneficiation. And for today's lecture we have tree treatment and sampling of ore. So before going to the subject, I just like to define sampling with an example. Imagine you are entering into a bakery and you want to try out a new sweet or something like a cake or a halwa. So normally you don't know the previous experience, what is the quality, what is the taste, how it's going to be. Normally what you do is that you ask for a sample, right? Sampling is nothing but in order to find the quality and how it's going to taste like in terms of food. And in our example, we do sampling in order to find the quality and the property of the ore. Okay, so when is sampling is possible, or when we normally do sampling is that imagine an ore is being depleted and you want to find a new place for an ore. So normally you go for first step will be sampling. If after geological survey, if someone is telling that particular area is full of minerals and ores, normally the next immediate step we do is sampling. So now sampling is nothing but an operation of taking a small amount of materials from a bulk, and it's called sampling. As I mentioned with the comparison with a bakery, imagine a piece of halwa. Like a small amount of material from the bulk is called sampling. Both of the it's same with the literal meaning also, and we can define it as the art of cutting a small portion of material from a large. And it is a representative of the bulk in all aspects, even in the terms of physical as well as chemical property. You can always understand this with the normal example what I explained in the early. So sampling is a statistical technique based on the theory of probability with mainly three objectives. So I like to read out the three objectives. Acquire the information about the ore entering the plant for treatment. So before the ore going for the treatment plant, we always want to get information regarding the ore. So sampling is done to find the properties and its chemical properties as well as physical property. Even by doing that, we can decide what kind of treatment it should undergo in the plant. So that is the first and the foremost objective of sampling. So second point is inspect the progress through the plant, and comparison can be made between optimum efficient treatment. So when compared with the example I said in the early, as I said early, that is if you are going to try a new cake, you will be having some idea of your previous experience, like the cake should taste like this. If it is chocolate cake, you might be having a previous experience. Okay, it's going to taste like this, I'm for sure, and it should have this kind of texture, this kind of fluffiness, and those kind of things might be in your mind. So by doing all this particular efficient process, what ultimately we are enhancing is that we are reducing losses and disclose recovery, and these are the objectives of sampling. So before going for a treatment plant, the ore should be undergo sampling in order to find the physical and the chemical property. So moving on, the process. So what is the process normally we do for sampling operation? So sample can be taken from any type of materials like dry or wet or pulp. So that means normally in every industrial mineral operations, either the initial product will be in a dry form or in a wet form. So sampling can be taken in any means, like even if it is dry or wet, but only thing is that the apparatus will be different for each process. And the second point is that a large quantity of sample is collected from a lot. So lot means the large quantity from which we are the bulk quantity, and as a primary samples are the gross samples. So known as the primary samples or the gross samples. So it's defined as a large quantity of sample is collected from a lot, known as the primary sample. So you can clearly understand that from the lot, the initial the samples taken from lot will be considered to be as the primary sample or the gross sample. And then normally we use a couple of equipments. We are going to explain the equipments in details in the further slides. So equipments such as hard tools, hand tools used as drills, shovels, scoop, auger, pipe, and slot are the slot samplers. So these are the normal equipments used for sampling. We have a slide describing about the equipments. And the next is the gross samples can be thoroughly mixed before reduction. Such reduction samples are called secondary samples and ternary samples depending upon the number of stages. So from this particular diagram you can understand what are the process we undergo for the sample preparation, and you can see the final test samples here. So it have to undergo couple of methods in the previous methods like primary, tertiary and secondary and tertiary methods, and these are the process. And moving on, we have the sampling ratio. Sampling ratio is nothing but it is defined as the ratio of the weight of sample taken by the sampling system to the weight of the lot from which the sample is taken. So in the numerator part, the weight of the sample taken, and in the denominator we have the weight of the lot. So this is the basic sampling this is a basic definition of a sampling ratio, and this particular sampling ratio is very important in order to find the performance of the sampling system. So that is a important indicator of finding the sampling system. So when sample is taken and subjected to analysis, there exists some chances of errors in single sampling. So I want to I go back to the previous example. For example, you are trying a cake for the first time. You can't judge a cake by the initial testing itself. You might be having some couple of samples, and you will be there are possibility of error. In the first sample there will be like some slight variation in the taste. So normally what you do, you either go for the second round or you will go for a multiple samples, then you ended up in a result. So same method here also. So if we go for single sampling method, the chances of error is very high, and in order to reduce that, we go for number of samples to reduce the error and to keep the overall errors within the tolerance limit. So that tolerance limit is decided by engineers. So which all limits we can accept, and error and its tolerance, that is decided by engineers. And the preferred method for obtaining a sample is from moving stream, such as conveyor belt, slurry pipes, or perhaps from the chute that a stream of ore flowing through. So normally sampling is done, or normally sampling process can be done intermittently. So that's why the material collected each time is called incremental method. So in intermediate method we can adapt. For example, if the ore is moving in a conveyor belt, you can go for sampling from that part itself, or you can do the sampling before that. From the extraction process itself, extraction from the rock itself, you can have a sampling. So intermediate sampling you can do. So that is the sampling, and that is the definition of sampling ratio. And next we have the conventional equipments used for sampling. So I mentioned a couple of names before in the previous slide, but here you can see a couple of images. We have conventional sampling tools like hammers and a chisel to collect rock chips. Next we have spades, shovels and mechanized loaders are preferred to signify large volume of sample materials. So this is an image of a spade. So in order to collect the samples, this is a smaller version of a shovel. And the next equipment commonly used for sampling are the supporting tools such as compass, global positioning system, that is GPS, and hand-held X-ray fluorescence, that is also known as XRF. That is actually a device in order to find the elemental data using the spectroscopic method. So you might you get an idea, because from this knob when you click there will be a ray of light passing out that will be in the X-ray level, and that particular X-ray will be bombarded over the surface, and from there will be some rays coming out, and you will get data from that. And normally this method are called spectroscopy. Spectroscopy is a method of finding the constitutional elements in a particular material. So normally in your material science, material characterization subject in your higher sum, you're going to study about in details the X-ray fluorescent method and those kind of method. But normally you can understand what is the real meaning of XRD, XRF, and another method is the various tools used for the process.
The chemical and metallurgical properties of this iron ore are critical to both the seller and the buyer. This gold-bearing ore is sampled in the pit prior to blasting and in the crushing and processing stages, ensuring optimum gold recovery is achieved. The mining industry is not alone in its need for accurate sampling of bulk commodities, but unlike other industries, it's essential to almost every stage, from exploration and mining through to production and shipping. Inaccurate sampling at any stage of the process can have a major impact on bottom-line profit. Automated sampling delivers exact and consistent sample increments, providing a true representation of the quality of the bulk commodity, which is difficult to achieve manually. Automation also greatly improves safety on site by protecting operators from the difficult and hazardous task of taking and preparing samples. Good sampling practice is governed by the use of proven system designs and procedures, which comply with internationally accepted principles. The objective is to reduce the primary increment in an unbiased way to a size that is manageable for transport to the laboratory without compromising sample integrity. ESSA designed, manufactured and installed the equipment here to ensure that the final sample presented for laboratory preparation and analysis will be truly representative of the original material. This has big benefits for business. At certain Pilbara iron ore ports, the customer has agreed to accept the sampling results at the port of export as final. This load port final agreement is based on trust between supplier and customer that the sample taken is correct. This requires trust in the equipment and processes being used. So, a typical configuration of a plant sampling system is a primary cutter, followed by at least a secondary cutter and a sample receiving device. Design of the primary and secondary cutters is crucial to achieving accurate and representative samples. All particles must have an equal opportunity of being sampled without any loss or contamination. Taking a sample from a falling stream is the preferred way to adhere to these fundamental sampling principles. ESSA has several linear cross-stream samplers to suit a variety of applications. The ESSA range of linear samplers work by moving across the entire width of the material flow, cutting the falling stream of ore from the end of a conveyor belt. They are the ideal sampler for ship loading conveyor belts. ESSA pioneered and developed ball screw direct drive sample cutting to ensure optimum accuracy and reliability from sampling systems such as this one. In keeping with the fundamental principles of good sampling practice, the cutter spoon intercepts the entire stream of material. The design combines the precision of an electric drive with the mechanical advantage of the ball screw, ensuring constant and uniform speed while in the ore stream. At the top of the discharge spoon, the cutter aperture has straight, sharp blades which cut the sample as the spoon moves through the material stream. Sample material is discharged below to a chute and feeder conveyor. Good sampling practice dictates that the cutter spoon opening is constant and that the capacity of the spoon is sufficient to collect and discharge the complete sample. During the process, there is no loss or contamination of the sample. In addition to the ball screw linear sampler, ESSA offers two specific linear samplers designed for large tonnage sampling. The belt drive linear sampler is a large stroke sampler driven by a toothed drive belt. Like the ball screw sampler, it's positioned above the conveyor discharge point with the cutter mounted below. Where the sampler has to be mounted below the discharge point, a synchronous belt drive sampler is used. A single electric motor drives two synchronised toothed belts located either side of the ore stream. This allows the sampler drive and cutter to operate on the same plane across the falling ore stream. This design is suited to high tonnage shipment conveyors. These belt drive samplers adhere to the same good sampling practices. A Vezin rotary sampler can be used in secondary, tertiary or even quaternary sampling. The technique employs radial cutters that rotate through the entire falling ore stream. Each cutter collects samples as it passes through the ore stream. The cutter must pass perpendicular to the sample stream, and it must pass a sufficient number of times to ensure a representative sample is taken. This process of sampling and subsampling is repeated until a representative sample reaches a weight manageable to an operator. Final samples range from 5 to 10 kilograms. Where it's necessary to collect more than one sample over a period of time, a rotary sample collector, or RSC, is used. The 8-container RSC is an ergonomically designed collector. It allows the operator to easily remove the samples to be transported to the laboratory for further preparation and analysis. Buckets of samples collected over a period of time are kept sealed and contamination-free during the complete cycle. The automatic sealing platform prevents dust ingress and moisture loss. ESSA takes advanced automated sampling systems one step further. Many leading commercial laboratories, port loading facilities and mine sites embrace robotic systems as their preferred method of sample preparation and analysis. At this port, dual robot cells process samples directly from the secondary sampler. As the ore is being loaded onto the ship, samples are constantly being analysed for moisture content and size fraction in accordance with international standards. A third sample is split off for chemical analysis in the laboratory, where once again ESSA's automated solutions ensure optimum accuracy and efficiency.
So these are some of the sampling operation normally done in industrial level, and I got these images from Mineral Exploration Principles and Application by S.K. Halder, and from this book I got these images. And initially we have the percussion drills, and you can see a larger version of a tripod kind of system. In order to drill the rock, we having a hammering system, and this kind of drilling method is called the percussion drilling, and this is the operation normally done. So this is the first and initial process we do in mineral beneficiation operation. So we have to collect the samples first, and then the sample will be going to further to chemical operations or labs in order to find the SA value of the ore. Here you can see a jackhammer drilling operation done by an operator in order to extract a sulfide ore, and this is a normal operation. And after this process, the rock bits we are getting will be undergo sampling operation. So this is a schematic diagram of an extraction process. You can see the description here: schematic diagram of surface diamond drilling method. So this is a drill bit we used for in order to drill into the rock, hard rock and rocky surface. You can see how the drill bits are going. This is the same process. You can compare it with an oil extraction process also, kind of same. Every minerals are extracted from the rock itself, so you can compare with the oil extraction process. Further videos will be available in YouTube. You can further refer for additional information, but in a general sense, so this is the process. So this is the tip of the tool we using, and we have diamond core by studded with the technical designs, and the tiny diamonds are the crowns composed on the super quality alloy. So this is a kind of prop we are using, and we have a setup like this, a tripod like setup we have, and we have the drills going into the rock, and this is the normal setup. So ultimately the part where our expertise comes is that here we need to fill out the log sheet like this. A sample log sheet is shown here, so you have to mention the project name and number and the date also, and we have to mention from and to the details, the information. As I mentioned earlier, the information of sampling have to be included in this particular chart, and the initial core size and the run length and the core percentage we are extracted, If the core have a certain color, we have to mention here, and the grain size we are getting, the structure we are getting. All these are the relevant information from which the sampling operation is done. So this is the vital information chart we have to report before any further treatment to be done on that particular ore. So when it comes to the towards the right, we have some terms, and we have the full form here, and we have BH, that is the borehole, and the BH process, BH, that is the BH number, and borehole, that means each extraction can be done in a multiple stages, and or each boreholes have a certain name. And the next is the OFM, that is the ore forming mineral, and we have a chart here, ore forming mineral, that which kind of mineral, what kind of a mineral you are extracting from this particular ore. And next is RFM, that is the rock forming mineral, and we have a description distinguishing between ore and a rock. And ore is a general term, whereas rock is a certain rock forming mineral we have, and we have to mention that how much percentage we have in our particular ore. And next term is RQD, that is the raw quality designation. That is a designation given for each rock quality, and that is, you can compare it with the standard value, and you can write the number there, RQD. Normally engineers do we have a certain chart in which they compare with the RQD data, and normally used to designate that column with that data. And we have a visual estimate also. You can have a comment over the ore you extracted, and you can give a remark over the last chart. So this is the ultimate aim of doing sampling, and you can understand how much important sampling plays a role in mineral beneficiation operation. So with that, this is the end of today's lecture, and thank you for listening to today's lecture. Hope to see you guys soon for the next lecture. Thank you.